Hello 10th class students, as we have finished the atomic structure chapter, now what we are going to do is we are going to start with the periodic classification of elements. When it comes to intermediate, these two chapters repeat: atomic structure and periodic classification of elements. So these videos are going to help you with this periodic classification of elements, better understanding of this particular chapter. So watch them and make sure that you watch them again and again and again, because these videos are the animated versions of the chapter, and therein you can easily understand what what exactly the chapter explains is the same thing you are going to watch in the television screen also. Thank you.
Hello friends, this video on periodic classification of elements part 7 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 6. As I told, a modern periodic table has periods and groups. Let's understand the periods in detail. So horizontal rows of elements in a periodic table are called periods. Correct? For example, this is one period, this is another period. And there are some properties of periods. For example, every period has a consecutive atomic number. For example, this is 11, this guy is 12, this guy is 13, 14, 15, like this, right? So the elements in this period will have consecutive atomic numbers. Also, the number of elements in the period is fixed by the maximum numbers of electrons which can have in the valence shell. For example, the first guy I have not written here, it is hydrogen and this is helium. So they have two. So the first is 2, only 2 maximum elements can happen in the period. The second is 8, lithium 1, this is 8, and then we have this guy, sodium, magnesium, this also has 8, this guy has 18, right? So that all depends, the number of elements is nothing but the maximum number of electrons in the shells, the outermost shells. And all the elements in a group has same number of shells because they have similar electronic configurations. And the maximum number of electrons that can be accommodated in a shell depends on this formula. You know this formula, 2n square, where n is the number of shells. Correct? And it is the valence electron which will be the first, and it is the valence electron which decides which guy will be the first and which guy will be the last. For example, the one with the 1 valence electron will be the first, the one with the 8 valence electron will be the last. Correct? Exception is the first one where helium has 2. I mean, you can say that the one with the 1 valence electron is the first, and the one which has all the valence electron filled is the last. We'll see this. First period, if you see, it has only 2 elements, hydrogen and helium, and it's called very short period. See the second guy, it has 8 elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. This guy has 8, this guy has 2, and it's also called short one. Similarly, the third one, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, it also has 8, also called short. And then we have a long one, that is 18, this guy has 18. This guy also has 18, right? This guy has 32. So it keeps increasing. I mean, there are 7 only. So this guy has the one which is found also. So that's the way it is. So you see that we have different periods. The first period is a very short period, then short and short, then we have long and long, and then we have very long and very long again. So we have 7 periods, and if you see, this all depends on the 2n square formula, right? It's 2, 8, 8, 18, 18, 32. Now let's see groups. These are all called groups because they have same chemical property. So if you see vertical columns in the periodic table are the groups, and please note they don't have a consecutive atomic number. If you see, it's 9, 17, 35. They don't have consecutive atomic number as we have in periods. And they have same valence electron, though. You see, helium 2 electrons, sorry, 1 neon 2 electrons, argon 2, or everything has 2 electron valence, 8, sorry. Very sorry, this is my exception here. This guy has 2, but apart from these, all has 8 valence electron. If you see here, everybody has 1 valence electron. This guy is 1, lithium is 2 1, sodium is 2 8 1, potassium is 2 8 10 8 1. Right? So if you see, each and every guy has 1 valence electron. So here also, but helium is the exception because helium's cell is filled with 2 atoms. So, but apart from that, all are 8. Here also, if you see, it is 2 7, this 2 8 7, right? So all are 7. They have similar electronic configuration. They show similar physical and chemical property. That is the main reason why they are grouped. This is the first, you can say, critical property. They have similar physical and chemical property. And the number of shells increase as we go down. If you see, this guy has 1 shell, this guy has 2, this guy has 3, this guy has 4. So the number of shells increase as we go down. So position of hydrogen, as I told, right? Position, this guy is placed here because it has electronic configuration similar to alkali metal. And we know that electronic configuration is a critical thing to arrange the elements. So there is no confusion now where hydrogen should be, right? But actually, if you see, hydrogen is a non-metal, the greens one are the non-metals, and it is placed with a metal. Right? The hydrogen is placed with alkali, but the property of hydrogen is not similar to alkali because it's very small in size. We'll see the position of metals and non-metals here. So if you see here, all these are metals. All these are metals in this guy. Right? All these are metals. Everything on the left hand side is a metal. So most of them is a metal except this guy. I mean, I can say like this. Yeah. All these guys are metal. Hydrogen and these guys are non-metal. Boron, silicon, germanium, arsenic, these are called metallites, which has metal and non-metal property. But again, that's still debatable. Some people say they are metallites, some people say they are metal, some people say they are non-metal. Again, we'll not debate here. I'm trying to say is everything on the left hand side from this line which I dot is a metal, and on this side is non-metal. Non-metal plus metallite. So we see there are very few number of non-metals and there are huge number of metals. And please note, we'll be covering only group 1, 2, 3, 4, 14, 15, 16, 17. Only these groups will be covering in this class. The other groups will, but will not cover because they're a little complex and they have different, little complex way of finding the electronic configurations. We'll study those things in the higher classes, but for this class, we'll study only these groups. Right? So group 1 has 1 valence electron, group 2 has 2, group 13 has 3 valence electron, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8 valence electron. So we'll study all these groups only, right? So when I'm talking about the properties and all, I'm talking about only these groups in this class at least. Now let's study some trends in the modern periodic table. If you move from left to right, I'm talking about the trends for the periods now, not for the groups. I'll take the groups later. So I'm trying to find the trends in the period, so I have to move from left to right. We see some variation in valence electron, atomic number, valency, size of atoms, metallic characters, chemical reactivity. And we also see variations in nature of oxides when we move from left to right across the periods, right? So we'll go through all of these one by one. The first is the valence electron for a particular period. So what we see is, on moving from left to right, the valence electron increase from 1 to 8. For example, if you see this guy has valence electron as 1 because EC is his electronic configuration is 281, correct? This guy, if you see, is 282. So valence electron is 2 here. This guy, if you see, is 283. The valence electron is 3. Similarly, if you see the number is increasing by 1. If you take this period also, it is 1, it is 2, right? So the number of valence electron increased from 1 to 8. That's the behavior we see when you go from left to right. Right? There's a exception in case of my first period, this guy. it increased from 1 to 2 only. It doesn't go to 8. And please note, I'm talking about these. I'm talking about only the 8 groups which I have discussed, to 1, 2, 13, 14, 15, 16, 17, 18. Because if you take the middle groups, the properties are different. It is complex, right? We're not taking that. We'll take only these groups, and we're assuming that periodic table has only these groups. And then we are talking about the trends. So this guy goes only till 2 and other goes till 8, only for those periods, those groups I have discussed. If you talk about atomic number, we observe that when the elements have consecutive atomic number, there's 11, this guy is 12, 13, 14, 15, 16, the list increases, right? So they have consecutive atomic numbers. If you talk about valency, you see that the valency increased from 1 to 4 and then decrease, right? So valency is the extra electron which it can have, or it has, or it can take, right? So the sodium has 1 extra electron, valency is 1. Magnesium 2 extra electron, aluminum 3 extra electron, silicon 4 extra electron. Phosphorus needs 1 electron, 3 electron, right? So its valency is -3. This guy is -2, -1. So if you see, it started from 1, increased till 4, again went back to 0, because they all inert gas and they have valency of 0. So this is how the valency behaves. From 1 to 4, then it goes back to 0. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on periodic classification of elements part 8 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 7. If you talk about atomic size, the atomic size decreases. Please note, this is a critical here. Please pay attention here. If you move from here, the atomic size, it has, let's suppose, this much size, this become this become this. This is all atomic sizes. It decreases. Why? Because, see, there is no extra shell, right? There is no extra shell. Same shell. Each of these has same shell. See the electronic configuration. This is 281, 282. So all has 3 shells. Correct. Now, as the atomic number increases, the number of proton in the nuclei increases. It has more and more positive charge. Correct. The positive charge increases. The positive charge increases, the power of the nucleus to attract electron also increases, right? So since the power is more, it attracts electron more towards itself, and thus the atom shrinks. Hope you understand this. See, if this guy has, let's suppose, 11 proton, right? 11 positive. This guy has got 12 positive, 13 positive, right? 14 positive and 15 positive. 16 positive, 17 positive, and 18 positive electron, like this proton. Now this guy, 11 proton can, the shells are not increasing, cells are still same. So this guy will not be able to attract this electron much, so the size is more. This guy, since it has more charge, it will attract electron a little bit closer. This guy will attract a little bit closer, like this, right? So since it has more power, it will attract electrons a bit closer, and thus the size will also decrease. Correct? That's how it is. In the class 11, when we study the atoms in a more detail, we will actually explain how the cells looks like, how the nucleus looks like. Actually, it is like this. The nucleus is just this much, and this is my atom. This is how it is. Right? Nucleus is only this much, and this electron keeps moving here, and keep jumping across different shells, and it moves in a spherical form. It's not the plate kind of form which I'm showing you. Actually, it's a ball kind of thing. It's it's a ball actually kind of thing. You can think this of a football, and these guy keeps moving here and there, keeps jumping here and there, and the way it moves very fast. It moves very fast, and you feel like it is a sphere. Similar to fan, if you see the fan, right, the blades, it rotates and you feel that it's a complete circle, but when it stops, you see that it has only 3 wings, right? It has only 3 wings, but when it rotates very fast, you feel that it's a complete circle, right? Similar like this. So we have this electron, this moves very fast here, and then you feel that it is a big sphere, right? So that's how it is. So in this case, if this has more charge, this guy can attract more towards itself. So this guy will not go out. This guy will be a little closer, right? If this guy is more charged, it is a little bigger, it will attract this guy here. So this guy may be this much big only. And that's why the electron, the atom size decreases as you go from left to right in a given period. Because there is no extra shell, but the nucleus has more power to attract electron and will attract electrons. If you talk about the metallic character, it decreases, but the non-metallic character increases. I'll show you why. See, metallic character is what? Tendency to lose electron, right? So I'll say metallic is the thing what? Lose electron. Now, if you see this guy, sodium can lose electron easily, but magnesium won't be able to lose electron. Why? Because same thing. So this guy has 12 proton, right? So this guy will bind the electron tighter. See, this guy sodium has only 11 protons. So this guy can go out. But this guy, let's suppose, has got 12. This will be difficult for him to go out, little difficult. This guy got 13. It will be all the more difficult for him to go out, right? So this guy is very easy. So I'll write 3 here. This guy, for him it is little difficult, and for him this guy is all the more difficult. Why? Because this guy is not able to hold it. 11 proton is not able to hold this properly, but 13 proton is able to hold this guy. Thus, if you see, the tendency to lose electron decrease, and thus metallic character decrease. Hope you understand this thing. Tendency to lose electron decrease, thus the metallic character also decrease. Also, if you see, sodium has only 1 extra electron, so it can easily give 1 electron, right? So it has more metallic. This guy has 2 electrons extra, so it will be a little hesitant to give 2 electrons. This guy has 3 electrons extra, so it will be all the more hesitant to give 3 electrons, right? And that's also one reason why the metallic character decreases as we go from here. The 2 reasons: one is the size of the nuclei, and the second is the number of extra electrons. If I talk about the non-metallic thing, this guy has 1 deficient, this guy has 2 deficient, this guy has 3 deficient, right? So if you see, for him to get 3 electrons is difficult. For him to get 2 electron is normal, and for him to get only 1 electron is very easy, right? So thus, if you see, this guy can easily get 1 electron. So this guy is more non-metallic. This guy is little difficult to get 2 electrons. This guy is little less non-metallic, and this guy needs to take 3. This guy is all the more non-metallic. All the more very weak non-metallic, you can say, right? So that's why it is. This guy needs 3, so it is little less non-metallic. This guy needs only 1, so it will do anything to get this 1, and then it is more non-metallic. So if you see, the non-metallic character is increasing. Hope you understand this. The non-metallic character is increasing and the metallic character is decreasing. Correct? So there are 2 reasons. One is the number of protons it has, and also the number of valence electron. It has 1, 2, 3, and then it needs only 3 to 1 in that fashion. If you talk about the chemical reactivity, so the same thing. The chemical reactivity first decrease and then increase. Why? Because this guy needs it has 1 extra. It can give 1 extra easily. It is more reactive. This guy has 2 extra. It will take some time to give 2 elements to electrons. It is a little less reactive. This guy has 3 extra. It is less reactive all the more. This guy has 4 extras, all the more reactive. This guy needs 3, right? This guy needs 3. So it will somehow get, this guy needs only 2, it will be a little more reactive. This guy needs only 1, this is all the more reactive. So if you see reactive, I'll write like this. I'll talk about the reactivity, right? So reactivity is going down and then it's going up. That's how it is. Reactive, less reactive, less reactive, less reactive, more reactive, more reactive, more reactive. Correct? If you talk about the nature of oxides, so if you see the basic nature of oxides decreases and acidic nature of oxides increases. This is all because if you see, if you go from here to here, I told metallic character decreases, right? And acidic character, non-metallic character increases, right? So same thing, metallic character will give you a basic oxide. So basic oxide decreases and non-metallic character will give you acidic oxides, right? So acidic oxides nature increases. Same thing, similar to the metallic and non-metallic, we have basic and acidic oxide. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on periodic classification of elements part 9 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 8. Now we'll learn some trends in the group. So if you go from top to bottom, we see some variation in the valence electron, valency, size of atom, metallic character, chemical reactivity, and nature of oxides. So we'll learn these. So we talk about the valence electron. All the elements in this group have same valence electron. If you take this guy, it's 27, this guy 287. So all these have, right, 7 valence electron in this case. Correct? If you talk about valency, all the elements have same valency. In this case, if you see, it's 27, so valency is 1, right? This guy also is 287, so it can take 1 to become stable. Valency is 1. So all these elements have same valency. If you talk about atomic size, the size increases. Why? Because the extra shell is added. So in this case, you may tell that in this case also the number of protons are increasing, but if you note, the shell is extra. So this guy is 27, there are 2 cells. This guy is 287, there are 3 shells, right? So the number of shells are increasing. Since the number of shells are increasing, the size is also increasing. If you talk about the metallic character, so if you go down, the metallic character will increase, right? But the non-metallic character will decrease. So the reason why it is happening is if you go down, the size of atom will increase. The size of atom will increase, right? The size of atom is increasing in both the cases. Since the size is increasing, the force of attraction between this guy nucleus and the electron is less. So in both cases, size of atom is increasing, right, as we go down, and force of attraction between my nucleus and electron is decreasing. Please note, it is decreasing, right? Why? Because it is far now. It is far, so the force of attraction is decreasing. Now, see, note here, if the attraction between this guy and this guy is weak, right, it can easily come out. Correct? So if this guy is not able to, this nucleus is not able to hold this electron, this guy electron will easily come out, and thus it will be more metallic. In this case, this nucleus was able to hold this electron tightly. So for this electron to come out, it needed some extra energy, right? So it was not reactive. But this guy, if you see, since the size is big, this guy is not able to maintain this electron, and this guy can come out very easily. Same thing here. When I'm talking about now, this is about electron going out, right? When I'm talking about electron coming in. Now, since if it is big, it will not be able to attract electron. It will not be able to. If it is small, it will be able to attract more and more electrons. If you see, because the power is more, right? The attraction is more. It is big, it is able to attract less electron. Since it is able to attract less electron, it is less non-metallic, because non-metallic is all about attracting more electron, right? So this guy is able to attract more electron. This guy is able to attract less electron. Since it is able to attract less electron, right, it is less non-metallic. I hope you understand this. See, in both the cases, the size of atom is increasing and the force of attraction between the nucleus and the electron is decreasing in both the cases. Now, when I'm talking about the losing electron, since there are two cases. For metallic character, you have to lose electron. So if I'm talking about losing electron, if my force of attraction is weak, I can easily lose electron. Correct? The force of attraction is weak, this can easily jump out. And thus, since it can easily jump out, I can say that he is more reactive. Thus, the metallic reactivity of this, or metallic character of this elements increase. But I'm talking about the non-metals. In this case, I am concerned this guy never gives electron. This guy always takes electron, right? This guy always takes electron. This guy always takes electron. Correct? So in this case, if you see, since it is going big and the force of attraction is less, this guy loses its capacity to attract, right? Because this is big, it is not able to attract even a single electron. You see, this guy is able to attract 1 electron, this guy is able to attract 3 electrons. But this guy is big guy is not able to attract single electron also. Since it is not able to attract electron, its non-metallic character is decreasing, right? And that's why we say that the metallic character increases as we go down and the non-metallic character decreases as we go down. And that's the reason why it happens. Please understand this little concepts involved here, right? In both the cases, size of atom increases and the force of attraction decreases. But if the force of attraction decreases, it's difficult for you to hold the electron. So the electron will go out easily and then you become more metallic in nature. But since the force of attraction is less, you are not able to attract electrons and thus you are less non-metallic in nature. If you talk about chemical reactivity, same thing. Chemical reactivity of the metal increase and reactivity of the metal decrease actually. Same funda here, because the size of atom is increasing, right? So this guy easily goes out, right? So this guy easily goes out because the size is increasing and this nucleus is not able to have control on this electron. This guy electron is more reactive, it goes out and is more reactive. In this case, the size of electron is big. This guy is not able to attract new electrons, so it is less reactive. But this guy, you see, is able to attract more and more electrons because this powerful now. Nature of oxides, all the elements have same nature of oxides. I think you have seen this in the Mendeleev also, right? The way he has grouped was with the base of nature of oxides only R2O3, RO, RO2, R2O. So if you see, all these elements in this particular group had same nature of oxides. Here also you can see that they have same nature of oxides, because nature of oxide also depends on the electronic configuration of the atom, right? So the number of electrons in the outermost cell, they are same, so the nature of oxide is also same. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on periodic classification of elements part 5 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 4. Now let's understand the Mendeleev periodic table, the best periodic table I can say, the best effort. So this guy, what he did was he arranged the elements based on their fundamental properties, atomic mass, and also based on the chemical property. But chemical property was given the first priority. So at that time there were 63 elements known. So his work was on this 63 elements. He first tried to find the relation between atomic mass and the chemical and physical property. And to find the chemical properties relationship, he selected hydrogen and oxygen as because they were very reactive and they formed compounds with most of the elements. So he reacted most of the elements with hydrogen and oxygen, and the way it react with hydrogen and oxygen, for example, this is some metal X and it reacted with hydrogen, it gives something, and X reacting with oxygen, it gives something, right? It may be Ra, maybe XH, maybe XH2, right? Maybe in this case, maybe XO, it can give X2O, it can give XO2, right? It can give X2O3 based on the property of the element, right? So it can react in different ways. So similarly with hydrogen also it can react in different ways. It can give XH3, it can give XH4. So based on the reaction of the element with hydrogen and oxygen, he grouped the elements, correct? And then he also used the atomic mass to arrange them, correct? So that is the formula of hydrides and the oxides which you get, the hydrate and the oxides formula which you get, was one of the critical parameter for classification element. So what he did was actually he took, for example, 63 elements, right? He took 63 cards. In each of these cards, he wrote this element name. For example, the element name is X, and this guy found some hydride XH and some oxide XO2, let's suppose, right? And atomic masses, let's suppose 58, let's anything. So this guy, he created cards like this. He created 63 cards like this with all the 63 elements name and all the hydrides and oxides and all the atomic mass. Once he had all these values, right, he know all the 63 elements name, he know the atomic mass of all the 63 elements, he know the hydrides and the oxides form. Now he grouped these elements based on these hydrides and oxides. They are the critical thing here. See, if you see the last one, the Newland's law of active, he arranged based on the atomic mass alone, right? So his parameter was atomic mass, and then he found that they have similar chemical property. But this guy, for him, the critical thing is chemical property, and then he's trying to arrange the atomic mass, right? And if he finds some missing objects, he has created gaps also in the tables. We'll explain that, but let's understand that both have a different approach. In the Newland's one, what he did was his primary concern was the increasing atomic mass, and then he found that coincidentally they have repetitive chemical property. For this guy, the critical or the main thing was it should have same properties, chemical properties. That is, the kind of hydrides and oxide form should be similar, and then the second critical thing was the atomic mass, correct? So he sorted these elements based on the similar properties and observed that most of the elements got a place in the periodic table and were arranged in the order of atomic mass, increasing atomic mass. So he was able to arrange them, correct? And he also observed the periodic recurrence of elements with similar physical and chemical property. That's what Newlands have observed. He also observed here also, correct? And on basis of all these experiments he did, he gave a periodic law, right? And he stated that the property of the elements are the periodic function of the atomic mass. This is the law he gave. This law is called Mendel's periodic law. It says that property of the elements are periodic function of atomic mass. Please note it's atomic mass. We don't need the atomic number now because atomic number is not even discovered by this time, right? Because the electron itself was not discovered. All this atomic mass which we use here is all found by the chemical reactions, because the base of all this was the Dalton theory. John Dalton gave this theory in 1804, where he told the mass can neither be created nor can be destroyed, and with that stoichiometry equations, they found, the chemists found a lot of atomic masses, and these was the atomic mass that was used by Mendeleev. I hope it is clear to you. So what he has done was he reacted these elements with hydrogen oxide. He found different hydrides, different oxides, and based on the hydrides and oxide found, he clubbed these elements, right? And then he arranged these elements based on the increasing atomic mass keeping in mind that all this form which forms similar hydrides, similar oxides are in a similar group. I'll show you the picture with that. I think it will be more clear. For example, if you see the hydrides can be R2O kind. Instead of X, they are using R here, or RO, R2O3, RO2, R2O5, RO3, R2O7, and RO4. So there are different kinds of hydride he found, and then he clubbed all these elements, right? And then the oxides for hydrides: RH, RH2, RH3, RH4, RH3, RH2, RH. These were the hydrides. So based on these two he clubs. For example, for these combination he found these many elements. So he clubbed all these into one group. Correct? All this into one group. All this in one group. So he grouped elements like this. Correct? And then if you see, he called his vertical columns as groups. So these guys were all groups. So group 1, group 2, group 3, and these were all periods, right? They are periods. He called this, used this word groups and periods, which are also used in the modern periodic table. So with this, if you see, everything is atomic mass here, hydrogen atomic mass, and then if you see, there's a lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, all the atomic mass, right? And based on the properties, this was the kind of periodic table he found, which was pretty good. Very few limiters in that, but it was very good actually. So we'll explain the merits and demerits of this periodic table. So let's do this. Hope you understand how he found this periodic table. So let's understand the achievement of this Mendeleev periodic table. First thing is predicted some of the elements which are not discovered at that time, because when he arranged the elements, he found that some elements are missing, because some of the elements atomic masses were missing, and then he guessed it. He guessed that okay, there will be atomic element which will be found in near future, which should have atomic mass of 68, and he called that guy as Eka aluminum because it used to come before aluminum, and that element was found in future, and we call that element as gallium. And he also guessed the formula of oxides and chlorides. If you see, he guessed that particular element which will have a formula of E2O3 based on his periodic table, and that's what it was. He also guessed the formula of chlorides or hydride to be like this, that is ECl3, and we found that gallium also follows the same suit. So he guessed the existence of some element which we not discussed at the time. Not only the existence of the element, but also the the chemical property of the elements. He could predict properties of several elements based on their position. As I told, these elements, right? I mean, they were elements for which the property was not found, but based on the position, he could tell, okay, this guy will form hydrides in this fashion, this guy will form oxides in this fashion, right? Because if you see, his periodic table is all based on the oxides and hydrides, right? If you see the way it is formed. So, for example, this guy, he has not reacted, he don't know how it reacts. But just because this guy is in group 7, he can say that this guy will form oxides like this. It will be Br2O7, and will form hydrides like this, BH. So that's what the purpose is, right? So in this case, let's suppose it's very difficult to react this guy with oxygen at that point of time. So what he told, okay, I don't know how to react, but I know that this guy La will react with oxygen, it will form something like La2O3. And if this guy reacts with hydrogen, it will form something like LH3. And that was true also. If you react those things in chemistry lab, and you'll see that that was the kind of reaction it goes through, right? So with just by looking at the position of the element, for example, Ti. So 10, if it reacts with oxygen, if it reacts, it will form TiO2. And if it reacts with hydrogen, it will form TiH4. So those were the kind of things he was able to tell just by looking at the position of the element in the periodic table. Also, he could accommodate noble gas, because these gases were discovered at that time only. So once he was done with the table, after that the noble gases were discovered, but he was able to accommodate that. So his table was able to accommodate that. That was one good thing about his table. Now let's see the limitation of this table. The first thing, the isotopes were also discovered that time when this noble gas was discovered, but the position of isotopes could not be explained. As I told, as isotopes are elements with same atomic number, right, but different atomic mass. Right, you see these are all isotopes of carbon, 12, 13, 14. So since they are different atomic mass, they should be different. They should be placed differently in the table, right? But that's what not his table allowed. His table allowed only carbon to be placed once. So the position of isotopes could not be explained that time, right? So this was isotopes were discovered after a long time after the Mendeleev proposed his periodic table. But once the isotopes were discovered, these isotopes could not get placed in the periodic table, and that was not very good. Correct. Also, some order of atomic mass was wrong actually in some case, and that could not be explained. For example, the cobalt was 58.9, it came before nickel, and nickel is 58.7. So this guy came, it is like this, 58.9 came, then 58.7 came. There was a debate on this, why it is happening like this, though it was only 0.2 difference, but generally it should be first will come, then second, then third, like this, right? It should not be the other way. So the wrong atomic mass order was not explained at that time, right? Also, hydrogen was not assigned a correct position because hydrogen has the property both of alkali metals and halogens. So if you see, hydrogen behaves like chlorine a lot of times and also behaves like sodium, right? So what should be the position of hydrogen was not confirmed because his classification of the groups was based on the way element react with hydrogens, right? Or the way element react with oxygen, right? So with this, hydrogen behave both as alkali and halogens. So the position of hydrogen was not clear. Also, he could not answer this question. Is it possible to have an element with atomic mass 3 between hydrogen and helium? This was the question. For example, hydrogen has atomic mass 1, helium has, let's suppose, 4, right? So can we have one element atomic number 3 here? Because atomic mass can be any number. It can be 4.08, 4.95, right? So between, let's suppose, 4 and 4.5, you can't say how many atomic mass can exist. Maybe 4.1, 4.2, 4.3, you can't say, right? But if it is something like numbers, I say that some quantity is number, for example, it has to be number, then I can say between 1 and 3, there can be only one number, that is 2, right? But if some quantity is not number, because this guy is not number, right? This guy is not, sorry, this guy is not natural number. So this guy is decimal number, right? So in that case, I can't see how many decimal number can exist between this particular number. For example, between 4 and 5, between 4 and 6, tell me how many decimal numbers can exist. There can be many because 4.5, 5, 5.2, 5.5, there's so many numbers. But between 4 and 6, how many natural number can exist? Only one. Correct. So since atomic mass was a decimal number, actually this is a non-natural number, so it was not possible to tell. If someone asked the question, can there be element between hydrogen and helium? The answer was, I don't know, because they can be, may not be, right? So these kind of limitations were there with modern periodic table. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.